Hey Adeline, how are you doing? I went on a quick walk right there. It's so nice outside. Wanted to get a little bit of the fresh air and everything. But what questions do you have? What should we do? What should we get started on? Let me know in the chat. We can get working on that. What questions are there? So drop those questions. We might do some MyPearson. It's been a busy morning. Usually my Tuesday, Thursdays are easy, chill, but it's been busy. Already given a test, got makeups. So many things going on. What should we do? Logging into Pearson. Having snacks. Snack food. Should be better. I left my lunch at home. Feel bad. Gonna go home and have it for dinner. So, questions on the Data Analytics 5? Yeah, let's do Data Analytics 5. Is it regression? Let me pull up the notes for today's live stream. Here it is, the live stream. Pull up the notes. Is it Data Analytics 5? No, it's not Data Analytics. What is it? It's not regression? We're not doing regression right now? Let me go see. What are we doing? Data Analytics 5. It is regression. Oh, it's regression, right? Oh, yeah. I was like, wait, it's regression, right? Yeah, let's go ahead and look at regression. Okay, got the notes up. I don't know what the note was for. Maybe it was for something else that I said. Oh, leaving my lunch at home. Thank you. Stat 201. Data analytics. Yeah, I know. That's what it was. Let me throw you some points for that. Data analytics 5, regression. Let's go check it out. Okay, and what I usually try to put these on here. Where is it? I always add these for our section. So I do have videos going over each and every one of these. I try to add them on. They really should be in the blueprint. MuBot's dropping the visualization playlist right now. The visualization playlist has links to do all of these. So we have right here regression. So I made a full video. Oh, I had to throw away my New York t-shirt. No more New York. And I'll put here, we're going to go over it right now too. Help video, click here. Okay. Now let's add in the link. Make it nice and big. That way, if people don't see this video, they might see this. Really? Really? There we go. Nice and big right there. Start the whole thing. Make sure all the settings are right. We do have the turn it in similarity on. So the turn it in similarity right there, all that good stuff right there. So do not copy each other. Do not copy. So with this, what is regression? So let's go over the theory behind regression. What is regression? So when do we use regression, Adeline? When do we use regression? What is regression? When do we use it? This is what you need to know for the test. This is what we need to know, and we'll be doing it in the assignment. But when do we use regression? When do we use regression? What's the point of it? So we've been going over the notes lately. Here are the notes. We're doing a lot of equations right here, a lot of solving, a lot of conditions, lots of ideas. When do we use regression? So when do we use it? Any thoughts in the chat on when we use regression? What's the point of it? We have conditions we check. QQ straight enough, no outliers, plot doesn't thicken. We need 2 quantitative variables to do regression. Yeah, and we'll look at that, Adeline, right here or not. We'll look at it. Here we check to see if it's a straight enough relationship, if it follows a straight line. Here we check to see if there's no outliers. There is an outlier on that right plot. And here we look to see if the plot doesn't thicken. So these are the conditions. QQ straight enough, no outliers, plot doesn't thicken. It'll be asking these later on, but known as quantitative variable straight enough, condition, no outliers, and plot doesn't thicken. And I would probably, if you're writing them in your report, try to go through here and write a description of, yes, it passes because it's 2 quantitative variables. I want to write everything out, but these are the conditions. I don't want everyone, don't copy what I say or don't copy, everything I do. But these are the conditions. QQ straight enough, no outliers, plot doesn't thicken. Probably call it 2 quantitative variables condition or quantitative variables. That way, if you're in another class, they know what you're talking about. I call it QQ. And I'll tell my graders, they take out points, give the points back. QQ means 2 quantitative variables. So you'll be working with a data set right here that I'm not going to use because I don't want to do the assignment. But let's check right here and see how to do it. You've got the used card data. I'm just downloading it for the moment. And we'll open it up here inside Jump. So you should see this. There's Pokemon. Windows need my credentials? No, you don't, Windows. Where'd the data go? Here's the data. So if you notice, we can only really do regression on a few of these because regression requires two quantitative variables. So what are variables that we could do regression on? Lot is more of it's not quite, I don't know if it's an identifier. Not an identifier. It's not unique for everything. ID is an identifier. So we could do regression on what here, Adeline? What could we do regression on? Can we do it on clean status or title and color? Could we do title and color? Could we do title and mileage? Could we do title and model? Could we do brand, which is only Ford, so we really can't analyze that because it doesn't have variation. Could we do state and country? Where can we do regression? And this means, if we're doing this, price and mileage, we could do price and mileage. We could do price and year. So you could do something like price and year right here, which I think price and mileage is the one you're doing. So I gotta be careful. I use the data set and do price and year. People might think that's the one we're doing. So I'm gonna use a completely different data set. You are doing right here, as it says, mileage, which is quantitative, and price, which is quantitative. So which one of those are you predicting? Which one of those do you want to see on the y-axis? Price. Does that make sense? You will fit the line to it. You'll make a residual plot, and let's see how to do this. So that is the what is regression. It is a linear relationship between two quantitative variables, and we analyze that relationship to see if we can fit the line and what the line tells us. So let's talk about how to make the output here. So this is how to make the output for data analytics 5. So I know, Adeline, you're wondering about the conditions. I will get to those. I'm making this here for, I guess, everybody, because that way they can see how to make the output. First thing you're going to do is take a random sample. Tables. Subset. You'll do 200 plus the last two of your UTID. You notice I'm not using your data. I'm using my own data. I'm just going to enter in a number. Make sure the last two are your UTID. Go ahead and click there and then click OK. And you do have a random sample of 200 plus the last two of your UTID now. So with this random sample, you will be analyzing two quantitative variables no matter what semester you're watching this in if you're doing regression. So you go to Analyze, Fit Y by X. Under Analyze Fit Y by X, you will now choose your first quantitative variable of interest, and I might want to predict attack by the defense of a Pokemon. So we have attack is being explained by defense, as in defense explains why there is a certain attack. Now we go ahead and click OK. Now when you click OK, you get a scatter plot. So we go ahead and we add the line by going to the red arrow and going to Fit Line. With Fit Line, it'll add the least squares line. We're actually going to close out the analysis of variance section right there because we won't need it. And we are going to add to this one more thing. We're going to go to the red arrow right here and go to Plot Residuals right there. Plot Residuals. You don't need all of these plots right here. We're only going to take the first plot. So I'm just closing out the extra things we're not going to look at. And I think that's done it. So there is the output. We might even be able to get this to move over here by clicking here and dragging and moving over to the right. Actually, that's not a bad idea. I do this in class. A lot of times I show the plot and the residual plot next to each other. And there it is. It also kind of illustrates some ideas. We can also expand this. It's kind of nice right there. Notice, and Adeline, do you see this, especially with class? Do you see these 2 points at the end? And do you see them over here in the residual plot? It's those, and it actually highlights them down there in that bottom one. But these 2 points right there on the end are the 2 points down here with negative residuals. How do we make a residual plot? You take your line and do what to it? How do you make a residual plot? Because notice these 3 points over here. That's these 3 points over here. How do you turn something into a residual plot which allows you to examine all the residuals? How do you do that? And you can click at whites. If you've got points selected, just select somewhere where there's not points to unselect. How do you make a residual plot? A residual plot is a diagnostic plot. It allows us to see what's going on with our data, make it horizontal, exactly. Like we talked about in class when we said, if you've ever had an MRI, the MRI is a diagnostic machine to see if there's problems. So you'll see right here, this is your plot, like when you go to the doctor and they look at you, and the diagnostic allows us to see if there's problems. So we call it a diagnostic plot. We diagnose issues. And I don't know. This one's kind of a weird one. This is not the one you're analyzing. You might call these up here outliers. And if you call them outliers, you might say there's some light outliers. You can highlight them and go to rows. And under rows, you can go to color. And you can select a color right here, like a nice purple, a light purple. And then you can go to rows and you can go to markers. You can put stars on them. And you can say those right there. So you can say I have a cluster of outliers up here, things that seem to be pretty far away from the central point of the data. You don't have to do this, but it can help with communicating, especially when you write in your report that you've marked the points with a, whatever you've marked them with. And it seems to be some light outliers. You could also mention that there does seem to be a little bit of plot thickening if this was the graphic you're working with, and you're concerned that the model starts out kind of strong and then it gets weaker towards the middle of the model. So do you see the vertical scatter difference right here, where at the start it has less vertical scatter? And vertical scatter means in this direction around the line. And towards the middle, it has greater vertical scatter. And there might even be a linearity problem at the end because it goes below. You can just mention a few of them. Just say there's a few points that seem like light outliers. Exactly. So with this right here, excuse me, we want to say how bad we think the conditions are. Now, it's really hard to fail QQ, two quantitative variables, because if you make a scatter plot, you have two quantitative variables. You want to point out any points you think are outliers. And if there's light out, you can say they're light outliers. We should be nice on the grading on these because it can be a tiny bit subjective. But you want to point out how bad you think the problems are, if they're bad or really bad. So definitely looking at it right there. I'm going to make yours real quick in the background here. I want to see what it looks like. It said price and mileage, right? I'm going to look at it and see what I think about it. I'm going to use the full data set. I'm going to take a quick peek at it. Price is the Y variable interest. Mileage is the X. You really want to look for big outliers. That's my hint for that. You really want to look for big outliers. Like, these are light outliers. You want to see if there's anything that really deviates from the trend. Like, really, like, ooh. If it looks pretty good, we've shown some in class today. We've shown what looks like good regressions. A good regression would look something like, I swear I drew a bunch of good ones. Where's my residual plot one I drew? This. This is a good regression that has no issues. The one right there. That's another good regression right here that has no issues. The one on the left has no issues. I did a bunch of ones that look like that. That really doesn't have any issues. You want to see things that really pop out to you. So if you look at these conditions right here, QQ is always passive as two quantitative variables. No outliers. You want to see if there's something that really jumps out to you. Do you see how, Adeline, this point really jumps out to you right here? Like, that really jumps out. Like, it's far away from the rest of it. You're like, ooh, that's a big outlier right there. So you really want something that jumps out and really screams, I am an outlier. And if you see plot thickening, you really want to see a major issue with plot thickening right here, where the plot gets thicker or thinner in certain spots. So you really want to look for major issues. You don't want to say like, these issues are pretty light. Like you can say like, I think there's some plot thickening towards the center with some light outliers. I think there could be issues with those two conditions. That'd be fine. Someone's writing that. And also this one's not as purdy as your guys. I think your guys is a little more easier to analyze, a little more easier. But now let's get to interpretations of coefficients, which a lot of people get wrong. Okay. So when you interpret coefficients, how many coefficients will we interpret? How many coefficients do we interpret? Any thoughts? We interpret 3 coefficients. 3 coefficients. Yeah, you could say it's light, but you don't think it's a big deal or something. If it is, yeah. You can also Discord it to me or something, and I'll check it out and look at it. We interpret 3 coefficients. What are the 3 coefficients we interpret? And this is on the test. So we interpret the intercept. Boom, Madeline knows right there. Technically lowercase, so don't worry about it. Technically lowercase. B1, it's B, sorry, that don't work. B0, B1, and R squared. Good job. So the R squared. So now, MuBot has the interpretations here. So if you're watching this, watch as I easily do the interpretations. The intercept. All you're doing is plugging in the values and write these down and practice them out. Notice where X is at. X is defense. Y is attack. So I'm going to highlight these as I say them. Use a color I haven't used yet. I'm running out of color. So here we go. I'm going to say it and highlight it. I might over-highlight things, but watch as we say it. When defense is equal to 0, we expect attack to equal 42.3. When defense is equal to 0, we expect attack to equal 42.3. I'm just letting those numbers in. What am I doing, Adeline? When you look at the interpretation, when x is equal to 0, expect y to equal b0. Notice you say 0 twice in it. When x is equal to 0, expect y to equal b0. And there's 3 things you fill in, your x, your y, your b0. I'm just letting them in. When defense is equal to 0, we expect attack to equal 42.3. You just plug them in. That's all you do. That's it. You just that's that easy right there. Does that, Adeline, is that pretty easy? It's just like, it's just plug in the values. You change x, you change y, you change b0. The slope works the same way. You do have to say if it's positive or negative, though, so watch out. I think I put that in here. Like, I know, Adeline, it's like so easy. And then we get to the test where like, I don't know what to say. And I'm like, no. For each 1 unit increase in x, we expect y to increase by b1 on average, or decrease by b1 on average. So we try this right here. For each 1 unit increase in defense, we expect attack to increase by 0.47 on average. There we go. For each 1 unit increase in defense, we expect attack to increase by 0.47 on average. It could be negative, so watch out because there are test questions that have a negative slope. And then people forget how to do the r squared, but the r squared is just as easy. It's blank percent of the variation in y is explained by the variation in x. So when asked for b0, b1 interpretation, yeah. Adeline, I'm glad I said that. You're just using the interpretations Mubot is putting in the chat, but these are pretty standardized across all students. We never say students cheated because we tell you what to write right here. We will tell people they cheated if we see other things like when you do your conditions, if for some reason your conditions are perfectly the same thing as someone else. I mean, they will probably be QQ straight and if no outliers, plot doesn't thicken. But if someone interprets the conditions the same way verbatim, then there's a bit of an issue or two. But these interpretations are so standardized among all students. I tell my graders, they're like, hey, they have the same slope interpretation. I'm like, we tell them to plug in the numbers. We tell you to do that. B0, I'll reverse it. B0 is the intercept. Good questions. B0 is the intercept because it's when x is equal to 0. And B1 is the slope because it's for each 1 unit increase in x. Notice how the slope, B1, is connected to x. So thus it's related for each 1 unit increase in x. Like, just think here. If this is someone's test score, use the following equation and tell me this is hours they study. So interpret the intercept for me. So here, the intercept value is what? And interpret it. So try to interpret the intercept value. So try that, Adeline, right here, just for test practice. Interpret the intercept of this that says score, predicted score is equal to 50 plus 5 hours times study. So what would be the intercept interpretation? So remember, the intercept is when x is equal to 0, expect y to equal b0. So what is the intercept interpretation? What would it be? Really good things to write down in practice. You get to the test, you know how to do these. So you have to say when x is equal to 0, we expect y to equal b0. So what would be the intercept interpretation? What would it be? Don't worry about being wrong. Just give it a shot. So you think when x is equal to 0, when x is equal to 0, we expect y to equal b0. So what would the interpretation be? So close. So when you say x, y, and b0, you have to plug in the values. So you ready? What is x? Just tell me what is x. In one word, what is x? In one word, what is x? In one word, what is x? It's hours. So when x is equal to 0. So when hours are equal to 0, when someone doesn't study, does that make sense? When hours is equal to 0, we expect score. Good job right there. Good job. to equal what? Let me throw you some more points, Adeline. When hours is equal to 0, we expect score to equal what? 50. Yep. Does that make sense? You see, I wrote the values below it. When x is equal to 0, we expect y to equal b0. So that might help right there to put the equation below it so you can see what lines up with what. So then the next one is, when we do slope, how would we interpret the slope? And good job right there, Adeline. Good practice. This is how you get it down. You look at it, you see it, you say it. And then, yes, Adeline, I like that right there. What would be the slope interpretation? So the slope is, for each 1 unit increase in x, we expect y to increase or decrease by b1 on average. So you have to plug in the x, you have to plug in the y, you have to plug in the b1. So what would the slope interpretation be? Because it's for each 1 unit increase in x, plug it in, we expect y, plug it in, to increase or decrease, pick one of those right there, by b1 on average. So what would it be? Give it a shot. Don't worry about being wrong. This is just how to interpret the slope. This is a major part of this video because MyPearson doesn't give you written questions. They just say pick the right answer, and because I do it in videos, people just like know which ones to click a lot of times. So if you can't write these out, that's like, oh no. What would it be? So when x, or for each 1 unit increase in x, we expect y to increase by b1 on average. So what do you think? I'll say the answer in a moment. So for each 1 unit increase in x, we expect y to increase by b1 on average. What do you think? So it'd be for each additional hour someone studies, we expect their score to increase by 5 points. Does that make sense, Adeline, right there? For each hour someone studies, we expect their score to increase by 5 points. So for each 1 unit increase in x, we expect y to increase by b1 on average. So that is how we would do it right there. Just a lot of practice, logging it down. And now we have to, for each 1 unit increase in hours, we expect score to increase by 5 points. Exactly. And then you can say on average. Some graders really care about that on average. I don't care, but just throw it in there.
It doesn't matter.
Don't listen to the rock. Some graders will take off if you don't say on average. Throw it in there just to be safe. If my graders don't give it to you, I'll tell them to give the points. Now we have to do the r squared. So when you do r squared, how do we interpret that? Good question, Darius Salmon in the chat. Off topic-ish regarding the least squares line. I remember us writing down, but unsure what else goes after that. I have it in my notes. What do you mean what goes after it? I might. Let me show that here next, Darius. But really good question. What do you mean goes after it? I don't know. I might know how to answer that. How do we interpret r squared here, Darius? We are predicting the attack from the defense. What would be the r squared interpretation? And then we'll answer that question. What would be the interpretation of the r squared right here? Blank percent of the variation. Oh, I didn't throw a percent. That's why no one was doing it today in class. Might have to update that. Blank percent of the variation. 24% of the variation in scores is 20% of the variation in hours. Wow. Adeline right there on fire. You got it. That's it. See, it's so easy. Just take it, times it by 100. You talk about it as a percentage. Oh, yeah. Yeah, let me make sure. I can throw those on there real quick. Thank you, Narav, right there. Yep. I have to manually add all the recordings, so that's why I can take a moment. I'm pretty good about, I've been trying to keep up with them, but I'm going over and doing that now really quick, because why say do it later and then just do it right now? And Narav knows some 320. We are doing all things regression right now. So today was a test, so I don't need to put that one on here. And Narav, check it out. We're about to update that recording. Going over here. Yes, we're talking about the conditions and Narav. Okay, it should be there. Thank you for asking. How much longer do I got on here? How much longer? As long as you want. As long as you want. You're welcome, Narav. Thank you for asking. 5,000 points for the chat right there. Please ask anything. That is the easiest way to get things done. It's just say, hey, Brian, you're live. Can you do this? I'll say, yeah, it just takes a second. It's just I have to every time think to do it. I wish it auto did it. I have to actually go in there and I have to click buttons. When do office hours end? The online office hours end in about 30, 35 minutes. And then the in-person office hours start over here in Stokely Management Center. So I think we only have a few more things right here. Let's look through the assignment. And there's a few more things. Name all 4 conditions as given in the notes in the textbook. Make sure to do that. People who chat GPT this are going to have problems. They're going to have problems. Report the value of the intercept and talk about it based on your stat tool interpretation from your notes. Report the value of the slope and talk about it. Report the value of the R-squared. Report if the linear relationship between the predictors and the response is statistically significant. So when you hear statistical significance, what do you need to look at to see if something is statistically significant? When you hear if something is statistically significant, how do you know if things are statistically significant? How do you know if things are statistically significant? By looking at the what? P-value. Ooh, look at that. Darius and everyone. And good, Daryl, good guess. We're doing Daryl 5,000 points right there. So it is the p-value of the slope. Perfectly set right there. The p-value of the slope. So you go down here and you look at the p-value of the slope, which is that value right there. So I want you to see something real quick. I'll make it in R. I don't have R open, but this value right here is below 0.05, thus indicating to us a statistically significant slope. And quote the value, quote what it is. It's less than 0.0001. But watch this. We're going to show you via simulation. So what I'm doing, I'm pulling up RStudio right now. I'm going to show you how to do a simulation. Remind me later to update. Okay. 103 untitled files. That's the way to go. That's how I go by untitled files. So we're going to write right here that y equals x is the vector 1 through 1,000. And y is equal to 40. Okay, what is 40 in this equation? Just tell me mathematically, what is 40? It is the value of the what? What is the value of 40? What is the value of 40? It is the value of what? Oh, I forgot my thing. What is the value of 40? What is the value of 40? 40 is the value of what? Does anyone know what 40 is? 40 is what? 40 is the what? That's what it is, but what is that? It's B0, which is the intercept, right? So you see the regression equation. Watch what happens now. If I go here and I plot the model. So if I visualize this model right here and make a linear regression on it, this is what I want you to see is I'm going to make a linear model from y and x and then plot the linear model. The linear model looks what? The linear model looks what? So there's the linear model. How does it look? All the points are where? Guess what all the residuals are? Oh, come on, R. We'll round it to 2 decimals around. Really, R? You can do that? There we go. That's better. The model looks how? All the points are perfectly on the line. Does that make sense? Every single point. So what I'm going to do here is I'm going to go plus random normal numbers. And let's go... I think I have to do 1,000 of them. Find out the hard way. With a mean of 30 and a standard deviation of 10. That did work. Okay, let's make the standard deviation higher. There we go. That's a perfect plot. Okay, so now, do you notice that things have a residual? This is positive, this is negative. So if I were to plot my residuals, there's the residuals. Do you see this point right here? Daryl, do you see that point right there? Do you see that point in this plot? This point right here, do you see it in this plot? Do you? Do you see these 3 points right here, like 1, 2, 3 at the start? Do you see those 3 points right there? How do we make a residual plot? How do we make a residual plot? We take the line and we make it what? You take the line and you make the line flat. You see this point at the start here that's kind of really super low? There it is right there. Another point back here. Do we see that? Yep, there it is over there. It's not nearly as low. This one is way lower. If you look at its distance, it's a good bit lower than what we see. Is it making sense that a residual plot is just your line flat and it allows you to see all the residuals of the model? I plotted all the residuals. But here's what I wanted to show to you. If we look at the p-value of the slope of this model, it is super duper significant. But what if we had a random x and random y? So this is 1,000 random x and 1,000 random normal y's. Oh, let me do that one. You got it, Daryl. And so now the p-value of the slope will be what here? High or low? The p-value of the slope will be high or low. Wow. Do x and y have a relationship right now? Yes or no? Do x and y have a relationship right now? Yes or no? Visually speaking, is there a relationship that you can see? Do x and y have a relationship, visually speaking, right now? Yes or no? No. So the p-value of the slope, logically, now we don't know this, but I've done a lot of these. So you would expect this looks like a random chance relationship. The p-value of the slope should be very what? High or low? Since it looks like they're not related and there's no slope here, the p-value of the slope should be very high or low. The p-value of the slope should be very high or low, which is the relationship they have, telling us if it's statistically significant. It should be super duper high. Look at that. It's the p-value of the slope. We could redo this again and get a non-zero intercept or something, but this is just, there you go. Someone might be like, oh, it's statistically significant. It's like, well, the p-value of the slope is what matters. We could set this intercept equal to 0. And now the intercept in the previous model is, darn it, all this. Let me decrease the randomness. Really? I set the intercept equal to 0. Decrease the randomness more. Here we go. That's should do it. Yeah. Okay, we really decrease the randomness. Really? Decrease the simulation for statistical power. 30 points. R is trolling me. There we go. That's what I wanted to see. The intercept is not statistically significant.
It doesn't matter.
Is this model statistically significant? Yes or no? That is a beautiful regression. It is statistically significant. The intercept might be 0. That doesn't matter. We have evidence the slope is not 0 via this p-value, which is extremely small. If you're wondering what that p-value is, if you don't know what that means about this right here. It's something close to that. I went one too few. I heard it when I did it. That is the p-value for scientific notation. So this is a very, very, very statistically significant slope. Does that make more sense on statistical significance? When the line is flat, we get a high p-value indicating that the slope could be 0. When we have a very sloped line with better strength to it, then we get a p-value that's closer to 0. So insignificant slopes are flat, close to 0, with high p-values. Significant slopes, that they could be up or down, because we just changed the value of the slope right here to -1. Sure, -11, why not? And there you go. So now it is a significant slope. It is definitely a non-zero slope, and that is ridiculous. If you get a model like that, you've got something amazing. R squared in this model is virtually 1 because we've explained almost all the variation. The residuals are actually very tiny. This goes from like -400 to 0. If you plot the residuals, the biggest residuals are like -4 and 4. And they're not even that big of outliers. There's just some randomness because the way I generated the random errors to be. Yeah. Does that make more sense? Let's do Daryl's question here. That was basically a mini lecture on statistical significance. And when you see non-zero slopes, they are likely to have low p-values. The stronger the slope is, and also powers. So many topics. But Daryl has a question about the weight with carrots. A newborn was 48 centimeters. I don't think it's carrots though. What does it say about him? What can we do next? Let's go to that question. I think this is on the quiz. quiz questions. I'm so hungry today. Okay. How's everyone doing today? Pretty well. I like that. I think sometimes, and I like that, Daryl. Like, I think sometimes we reflexively say, "Well," and I'm doing well. It's been a busy week. I'm doing well too, though. I'll tell people if I've had a hard week. I'll go over here. You know, people. I think I'm doing pretty good. It's been a busy week. It's like, oh, so busy. It's like we hit the ground running, and then you're like, "I got work to do. Go work, stretch out." Oh no, I was doing my workout last night. I got a chest is sore, and now ours Pearson's broken. No, life is good. I gotta focus on the positive. Gotta stay happy. Gotta hope MyPearson's not broken in the background. Is it gonna work now? Watch MyPearson just not work. Manager at a bookstore. Yeah, we can do that one if MyPearson works. I might have to actually pull it up. Oh, hey. Come on. Breakfast cereal is the most important meal of the day. Really? So number two, is it number 2 or number 1? It looks like number 1, right? I think it's number 1. We'll come back to that here. I think we've got the carrot or the baby length question. And I think question 1. Quick question. Be right back. Hey, we are back. We're going to do the manager at a bookstore, and then we are going to do number 1. We'll go back, Daryl, and we'll do that question. We've got it, and we'll put it in today's video, and it's in yesterday's video. So let's go right here. 42, 23, Stat 201, MyPearson, Quiz 7, the manager of a bookstore. Okay, so here's what we should do. We have right here the data. So where are we going to go bring this data? Where should we go bring this data? Where are we going to bring this data into? How are we going to solve this? A lot of problems look like this. There's probably like 4 or 5 problems that look like this. Where are you going to take this data? You're going to go copy to clipboard and bring it over to where? Where are you going to bring the data? Jump. So we're going to hit Command C or Control C, Mac versus PC. Inside of Jump right here, we're going to go here and click on Jump and go to File, New Data Table. I'll pause right there. You can also hit Control N or Command N. You can do that in Word or Excel, and it opens up a new instance of whatever you're using. So, File, New Data Table. Don't click inside of it. Go here and go to Edit, Paste with Column Names. edit paste with column names. When you do edit paste with column names, you'll get the column names at the top of the screen. With the column names at the top of the screen right here, we are trying to predict sales for the company. So with us predicting sales, we want to go to Analyze, Fit Y by X. With Analyze Fit Y by X, we put the Y variable of interest, which is sales, Y, and the X right there. How are we doing, everyone? Are we doing good? Just give me a yes or no in the chat. So that was copy the data, open up a new instance of Jump with File New Data Table, and then edit paste with column names. They have to be blue. If they're not blue, if they're red, they're not done properly. Great job, Daryl, right there. And so now we're going to go ahead and click OK. Once we click OK, we get the model. Looks like a good linear model, so let's add the line to it. We're going to go to the red arrow and go to Fit Line. So now that we've gone here and we've gone to Fit Line, you can see the linear model's been created. So what is the slope and what is the intercept? Just tell me to one decimal, what is the intercept or what is the slope? Just tell me to one decimal. Might be like, Ryan, I couldn't see them. What is the slope? What is the intercept to one decimal? Oh, man. What are any of those quantities? What is the slope? What is the intercept? You can see them down here too. The estimate of the intercept, the estimate of the slope. Slope is 0.8 right there. Yeah, there's the slope. So we can just grab this number right here. It says to 3 decimals. So this will round up, and we'll grab it right here. And this is for each additional worker, how much more we expect to make. It means on average, we would expect an increase in this amount of money by the number of workers. On average, the total sales will be equal to, means on average, an additional increase. Not that it is this, but for each additional worker, we would expect sales to increase by this much on average, and we'd have to multiply by 1,000. So what is the intercept? The intercept is what value? You have to look over here at the output and round to 3 decimals. What is the intercept for this problem right now? You have to be like, where's the intercept? Where's the intercept in this output? Where's the intercept? Jump makes these questions so easy. Without Jump, you have to do a whole bunch of math in the background. People do these by hand. It's like, wait, I can just plug it into Jump and it just gives me the answer. Like, yeah, there you go. You won't be doing the math by hand you will do some math on the test, but you won't do a lot. At least, there's a lot that can be done without math. You'll do less than you would need to. The intercept is right here. The intercept is also kind of illogical because it's when x is equal to 0. The intercept is down here, which would be when how many people are working for us. The intercept, which is down here, is when how many people are working for us, which is kind of illogical. So the intercept is when how many people are working for us, which is kind of illogical. The intercept is when 0 people are working for us. When salespeople equals 0, we expect these sales in thousands of dollars to be equal to $9.13 thousand. So it doesn't make sense. It would mean that on average, let's hear it here, when there's nobody working, it means that on average, we would do the intercept value times 1,000 with 0 salespeople working. It doesn't make sense because it's unlikely that there'd be any sales if no one's working. Write out the regression equation. Well, it's written over there on the side. 9.136 times 0.817. Did we round that other one? We did. Wait, and I did it properly, right? Yes. It's weird to me that they do slope then intercept. I prefer to do intercept than slope. If there's 17 people working, how would we find that answer? How would we predict what the sales would be if there's 17 people working? If there's 17 people working, how would you predict what the sales would be? What would you do here? So it says if 17 people are working, then what would you do? Plug it in for X. Just do that. Excuse me. So we go right here, and we do 17 times, and there we go. We had the 9.136, and then we times by 1,000 because this is in thousands of dollars, and it's 23,025. And we get the following. Now it asks, what is the residual? And the residual is 975. How'd I do it that quick? Well, think about it. If this is 23 025, and that is the predicted. That means the line would be down here at, if we were to trace and do the predicted value, that would be the predicted value. And the actual value is somewhere up here at 24,000. And we just take their what? To find the residual, we just take their what? The difference. Great job. The residual is the difference between the actual and the predicted. And it tells us in the problem that it actually costs 24,000. And remember, if it has a positive residual, it's above the line. So I knew that it was, this much more than predicted to be. And try interpreting that it's $975 more than it was predicted to be. So has our original estimate under or overestimated it? Did we type under or over in the chat? Did we under or overestimate it? Did we under or overestimate it? Did we under or overestimate it? Which one did we do? Did we under or overestimate? Did we under or overestimate? Don't worry about being wrong. I got to throw you some points here. Did we under or overestimate it? Which one do you think? The visual makes it easy. You can see the answer to under or overestimate behind my head. Did we under or overestimate it? Which one? We underestimated it. Don't worry, I'm throwing you some points right there. So what gives the estimates? Is the estimate the dot or is the estimate the line? Which one of those is the estimate? The dot or the line makes the estimate? Which one of those is the estimate? Is it the actual or the predicted? The line gives the predictions. Line is all y hats. So which one of those is the estimate? The estimates all come from the what? Yeah, exactly. That's the predicted is the estimates. These are all the estimates. So we've underestimated what it actually is. The actual is above it, so we've underestimated. I know that tricks people all the time. Like this one is so commonly missed. We've underestimated the actual. There we go. It's a really good question. It's one of my favorite ones. Yeah, you just have to see it. Like the visual makes it easier to understand. So that's why I was trying to draw things out. When you realize that the predictions are the estimates, so that's what the estimate is, and it's above it. So we've underestimated it. It's higher than it was estimated to be. The residual is positive, and so we've underestimated it. So the prediction was lower. So yeah, there we go. Good stuff. Daryl, did you have the other one? Wait, did you want to do the homework question? We do a homework question. We do another quiz question. How do you know what is meant to be X and Y when you put into jump? Did they state that clearly here? The manager wants to predict sales. There we go. Predict means the Y variable of interest. So we want to predict sales. Really good question. Thank you for asking right there, Daryl. 1,000 points. When we say this is the thing we want to predict, that means Y. So if that's the predicted variable, that is the Y variable of interest. So we want to predict sales, and whatever we predict goes on the Y. And then the explanatory goes on the X. Really good question. Sometimes I do those things so quickly because I've done these problems a lot, and I might read something that just clicks in my head really quickly, but please ask those questions. That's like, how'd you know that? Well, it says predict Y, or predict the variable of interest. So, yeah, and yours probably does the same thing. Did you want me to do one of the homework ones, Daryl? Do you want me to do homework question? Do you want me to do homework? Homework? We do more quiz questions. I'm trying to think when these are due. Are they due tomorrow? Are they due today? Chapter 7, due Thursday. Everyone's like, I got time. I don't got to start this. No. Thank you, Daryl, and thank you, Darius. Starting early because these are tricky. Jumping worked out. All right. Granola bar's getting to me. Oh, man. I'm been catching up on sleep lately. Looking over here. Let's chill. We got chill moments. once you get it through, it's pretty... Yeah, exactly. Darius, shout outs to you, man. Like, once you do it, it gets pretty simple. Game night. Game night. Oh, Family Feud. Oh, that sounds fun. That sounds fun. Pretty much, I was doing like... We'd kind of gone through the notes last time, and I was kind of doing my own version of the notes this time. So... I was like, let me like cover everything, and like that's why I think today's lecture was really good, where we really went in depth on each thing, and I basically was like, here's how you check this, here's how you check this, here's how you interpret the slope, here's how you interpret the intercept, here's how you solve the equations if you're asked for the residuals, here's how you solve for the predicteds. So we went through and did like the Charmander example. So I tried to think up, I was literally sitting there thinking of how many questions can I ask you that would appear on the test. That was like my whole train of thought the whole class. So like I was like, I know we ask conditions on the test. I know we say solve the equation. I know we say solve residuals on the test. I know we ask if residuals are negative or positive on the test. I know we asked to look at residual plots on the test. I know we asked what a residual plot is on the test. Like I was thinking, I just kept thinking test question, test question, test question. Yeah. No, today was so test relevant. And that's why I'm like, we gotta have people here. We gotta have people answering these questions, because I'm not like literally giving away test questions, but I'm pretty darn close to giving away test questions. And just like I try to come up with as many as I can come up with during class. Like that's my whole goal, is to endlessly come up with test questions. And that way someone gets to the test and they're like, oh, I remember that. I remember how to do that. I remember how to do the whole test. Oh, man. Oh, man. Let me take a short break. It's been good office hours. We got data analytics done. But people are going to be here for Chapter 7 tomorrow. I'll try to remind people. I'll be like, come on, Chapter 7. Swing by. We can do the full quiz, whatever we want to do. But with that, I might head off a little bit early. There's going to be some food, I think. Oh, someone said Leslie here. Yeah. You're welcome, Madeline. There we go. Office Moira is the best. Shoutouts, 5,000 points for Moira right here. We're going to head off, replying to some emails, getting everything done. Thank you, Adeline. Thank you, Darius. Thank you, Daryl, all for being here. Make sure to swing by, ask questions. We can work on as many things as you want. We're going to be in person here soon. Bye for now, everyone. Bye.
We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours.
This ends now.